I don't know.
You didn't see the plan, no?
Loading. Oh, come on. Hey. Still loading. Okay. So, what I was going to do for revision is the exam from Friday. I'll put the questions up on the screen. So you did better this time than last time. Still not good enough, perhaps, yes, but still better, which is good. Let's have a look at the quiz. Okay, question 1. Right, a boat sails 1 kilometre east and then 1 kilometre south. It took 2 hours to do this. What's the average velocity? Okay, so in number 1 here, the boat travels, what did I say, 1 kilometre east? Is it? Yeah. And then 1 kilometre south. So the average velocity would be southeast. Yeah? And I said the average velocity would be v kilometre hour southeast. So, and we also know that this takes 2 hours. Yeah? So if we think about it as distance, speed and time, it'll be distance divided by time. Yeah? But the distance isn't 2. What's the distance from here to here?
1.
No. It's root 2 from Pythagoras.
Yeah.
So it's root 2 divided by 2 is the v. So that would be root 2 divided by 2. Now, do I want it in meters per second? I do. So it's 0.707 kilometers per hour. And then so that's 707 meters per hour, which is 0.196 meters per second. Yeah? Let's see. What did I just say? 196. Yeah, you can have a look at your responses if you want to open them up. You think you got it right? Let's have a look at it again. Anyways, the next one here with the block. this is... Oh, my answer is wrong. I did mine meters per hour. 0.196. So I'll regrade them because maybe some people's grade will now go up if you entered that. Oh, come on. Wasn't that anyways? Let's have a look. Okay, next one anyways. For me, number 2 is it's a 10 kilogram block and the angle is 30 and the force is 20 and the friction force is 1/10 the reaction force. Okay, and actually let me just... Right, let's draw that. So it's a 10 kilogram block. And what was the angle? The angle was 30. So this one here, and what was the force? 20. So this is 20 cos 30. And this one here, that's 20 cos 30. And this one is 20 sine 30. There's a reaction force here. There's a weight here, 10g, yes? And then there's a friction force here. How big is this friction force? Let's see, not in this case, 1/10 of R. 1/10 of R. Yeah? So you have R plus 20 sine 30 equals 10g. Yeah, so that. Yeah, R is 88.1 newtons. So 1/10 R would be 8.81 newtons. So the total force is 20 cos 30 minus 8.81. The total force this way.
I did it like 8.81.
Oh, so you decided to get most of it right, but not all of it right.
Yeah.
Interesting decision.
Yeah.
Oh, guys.
Same mistake, okay.
8.51 newtons.
I have to ask some questions.
Hang on. I think I wanted the acceleration, was it?
Yes.
So the acceleration is 0.851 meters per second squared. So let me just put that in. Yes, Mayor. You said you had a question.
Oh, because there is the same question in the book.
Yeah, I believe so.
We
Yeah.
didn't get an acceleration.
Yeah, we didn't get acceleration. So I just saw it and it the value was same as well. So for cheating you also need some.
Oh, just a mistake. Minus 8.81. That's okay. Yes, we know the mistake.
Yes. Let's see. Can I regrade? Yeah, but I'm trying to regrade it because one of the answers was wrong. Regrade all. I don't know if anybody's results change.
I got 11.
You went up a little?
Yeah.
Congratulations. Alright, so let's have a look at tree. I was looking at some of the results. So, some questions nobody got right, but most questions at least one person got it right. But there was a couple of questions, I don't know if this was one of them. I don't think so. I think somebody got this one right. What you have is inside the sphere, there's a ball rolling around, and this distance. Oops, where's my pen stop working? Come on. Yeah, this distance here is 1.3. This distance here is 1.2. So this distance here is 0.5. That's from Pythagoras. Yeah. So if you were to look at this ball, there's two forces acting on it. a reaction force from the wall and the weight. And do we know the mass? We don't. So that's just mg. Now what you need to do is break this or up into this direction and this direction. So this angle here is theta. So this is or cos theta or sine theta. And in fact you can know what the theta is. It's tan inverse 1.2 over 0.5. 67.4 degrees, or 38 degrees. So on the top, let me just do cos the answer. So this one here will be 5/13 or, and this one would be 12/13 or. So these are the three forces.
How is it 5/13 and...
That's just cos the angle. Works out to be that. Yeah. Like if you type in sine of this angle, it'll be 12/13. Yeah. So you know that 12/13 or, what should that equal? That should equal mg. Yeah?
Yeah.
So then or equals 13/12 mg. We're good with this?
Yes.
Yeah. Now what type of force is this? Well, this is a circular force. So you have this formula, I don't know if you remember it, the centripetal force, yeah. I think mv squared over or is the centripetal force, and that should equal 13/12 mg. No, I'm sorry, that should equal...
Oh, you make F equals ma and a equals b squared over r.
Yeah, yeah. And that's to equal 5/13 or. Now we know some information here. We know the or is 0.5, and we know the big or is 13/12. So cancel, and we can get b is square root 0.5 times 5/13 times 13/12 times g. So I just replaced the or here with what I have from earlier. So square root 0.5 times 5/13 times 13/12 times 9.81, 1.43 meters per second. Okay, next one. Are you writing this down, Andy? It's recorded. Okay, this one here. Two men are carrying a 200 kilogram tree, which is 3 meters long, and the center of gravity is 1 meter up from the trunk, and both men carry it 10 centimeters from the end. So what's happening here is we have our tree, but because of the shape, the center of gravity is here, not at the middle. So what is happening here is this is 1 meter, this is 2 meters. That's what I said in the question. And that the men carry it 10 centimeters from the end. And the weight, are we told the weight? 200 kg. 200 g, yeah. Right, so if I call this or and this s, we have or plus s equals 200 g as normal. So 200 g is 1962. Okay, so that should be okay so far. And then what do I do next? Turning force. Let's take this as the turning point. So this way is clockwise, and this way is anti-clockwise. The distance from here to here is going to be 1.8. So 1.8 or should equal 0.9 s. So 1.8 or minus 0.9 s should equal 0. I took this as the turning point.
Why?
You're allowed to take any point as the
Yeah.
turning point.
Yeah, but why
This
did
one made it easiest for me. Oh, but yeah, actually, you know, maybe taking or s would have been even easier, because then you could get one answer straight away then. Yeah. Did you guys take or?
Yes, I did take off.
Well, let's take or then. We'll get the same answer though. What point did you take, Musharif?
Yeah,
You took or. Fine, okay, so we'll take or. So this one is then it's not clockwise and anti-clockwise. Then what's this one going to be? Clockwise, and this one anti-clockwise. So the distance from here to here is 1.8. 1.9, sorry, thank you, 1.9, or should equal 0. What am I doing? Oh, sorry, so sorry. 1.9 200 G, and then the distance from here to here, that should equal, this is clockwise, should equal anti-clockwise. No, it's not quite 2. What is it? The distance between or and S is only 1.8.
0.1.
Yeah. S.
Yeah.
Right, so we can get the S now.
It's 2 plus 1, 3.
0.1 from here and 0.1 from there. That's 0.2 minus 2 is 1.5.
Sorry, no, I'm wrong.
Yeah.
2.8, not 1.8. It's 3 in total.
Oh, it's
3 in total, yeah. Okay, so 1.9 times 200 times G divided by 2.8. So I get my S is 1330, so then I can get my or. And my question was what? The lazy man complains that he has more to carry than the heavier man. So my question was, what was the difference between the two of them? And the answer is the difference of 700 newtons. So it's 700 then. So where did this one go wrong?
The center of gravity part.
You put in the middle?
Yes.
Aha. You won't make that mistake again. Alright. I don't know if anybody got this cantilever one. Oh, do you know what? There's one thing which nearly everybody did wrong. I said the weight was 8 newtons. I didn't say the mass was 8 kilograms.
It's not 8 G.
It's just 8, yeah.
Right.
Okay. Some people went with, I think, 8G. Did you?
No, I didn't do it, but I noticed that. It's on the.
Okay. Right, so it's a 3-meter rod and a 5-meter string. What number is this now? Am I on? 5. So this is 3 meters, and the string here is 5 meters, and this is 3 meters. So therefore, this piece here is 4 meters. There's a force here, and a weight here of 8. And what did I ask for? What is the tension? Yeah. Now, in fact, if you wanted to, you could have done this as a... Come in! Who's this going to be, Mahmoud or Fawam? Oh, why are you so late? Yeah, why are you so late? You got that? You got the cover sheet?
Huh?
Later, give it to me later then. Why are you so late?
Happy, she's happy, she's
Sit down.
She's happy that she's...
I heard you missed your writing exam.
Yeah, I feel tired, so I get
Me
up.
too.
Yeah.
She's back. Hello?
I smell your lunch. What's your lunch?
I don't know.
Okay, you'll find out later, I guess. Right, so as I was saying, are you going to get in there, is it? Yes? Okay, come on. Don't hurt yourself. Very good. Right, so as I was saying, you can do this as 3 forces if you want. So you know that they must meet all in the same spot. Not quite how I drew them here, Let me just clean that up a bit. But I don't feel like that's how people went with this. Did anybody use that? No. But you could have. You could have. They all should meet in the same spot here. But, like I said, you didn't need to use that or even know that. Okay, so, first piece of business. Do I know this angle here? You can know it. It'll be tan inverse 4/3. So, we can get the t here. This is t cos. And cos will be 3/5 when you work it out. And this will be t sine. And sine will be 4/5. So, you have... I think I'll look at just the vertical, or even...
You can just take the R as the turning.
Yeah, just take yours as the turning point. I don't even need to look at this direction. So if I just look here, this one would be clockwise. This one here? No, this one here?
Cancel.
Cancel, yeah. So this one here?
Oh, you mean the cos, okay.
Yeah, the cos. And the sine one here? Anti. So you can get 1.5 times 8. That should equal 3 times 4/5 t. Right, so then let's see what the t is. I got 5 newtons. Yeah.
I said the answer is 49 and you put this mean correct exactly.
No, 49. No, I might have only given you half marks for
Yeah,
that.
it's orange, but
Yeah, the reason you got half marks is because you were off by about 10, which means I thought that you probably forgot about the G, and so I gave you some marks because I felt you probably did it the right way, but because you were off by 10, like for example, if you do 5 times 9.81, you get 49.05.
that's all we have.
Yeah, so I figured you included the G when you shouldn't have, and that's why I gave you half marks. Yeah. Did you include the
I
G?
knew that it was 8, but I don't know why I included it after that.
Well, you got half the marks anyway.
The method yeah, like it's 9.81 in the calculator always, you know.
How much
I did that on purpose, I'm afraid. Yes. This?
Yeah.
Not till definitely after the break. I have the math assignment correct.
Oh, you're gonna correct them?
Well, for my students, and then I'll have to double check the other ones
No,
too.
these. Are you gonna correct them?
Oh, these I'm going to correct, yeah. Okay, can we go on to the next one? So this is 5 here. Okay. Yeah, this one I'm surprised that not everybody got it. I wanted the periodic time of a 1 meter pendulum. So, I'm surprised not everybody got this right, to be honest, because the formula was it, no, that's the other one, there's 2 of them. 2 pi root L over G. 2 pi root 1 over G. You got this one? Okay. Yep, so 2 seconds basically would do.
Which one?
This
This is-
one.
I wrote 56.
But you're saying the correct answer is 6.2.
Did I?
This is the other one. There are 2.
There's 2 pendulum questions.
This
One for
picture
the
is-
speed and one for the time. It's the same picture.
Just check.
Oh, why did my tree not enter?
Oh, my answer is correct.
Oh, I didn't put in my answer for tree. Huh?
Yeah, this is right. It's 1.
Oh, I typed in a comma instead of a dot. Okay. Right, 7 now. Water's pumped up a 10 meter building, 2 kilograms per second. How fast the water being pumped?
Okay.
Yeah, so this one here, you have a tank of water here and a tank of water here, and it's being pumped up a height of 10 meters, and what happens is every second 2 kilograms of water gets pumped up, or put into the pump. Now here the water is at rest in this tank, so it has no kinetic energy and no potential energy. And then up here, when the water is sitting in this tank, again we'll say it has no kinetic energy, but it does have potential energy. This, you can see, means the energy is not balanced, because at the start it's 0 and at the end it's not 0. So this extra energy came from the pump, yeah. So anyway, the extra energy is the potential energy. So per second, the potential energy is mg h. What's that? 196. Yeah, 196.2 joules every second. Now, what was I looking for? How fast is the water being pumped at in meters per second? Right, now, this is a bit different to what I was doing in class. I made it a little bit harder. So, what's happened here, if you think about it like this, true, it has no kinetic energy here, but what happens when it enters the pump? It does have kinetic energy. This is how it gets up to the top, of course, because it's being propelled. Yeah. So basically, the kinetic energy at this stage in the pump will have to equal 196.2. So that's a half times 2. V squared equals 196.2. So the V is just the square root of that. 14. Did you mess up with the 2.5 maybe? So 14 is the answer here. The rocket question. This wasn't as hard as people thought it was, but let's have a look at it. The Saturn V rocket, during stage 1 of its flight, reduces its mass from 2.3 million kilograms to 0.48. So, what happens here? It goes from 2.8 million kilograms to 0.48 million kilograms, because it's burning the fuel. And this took, 2.3 to 0.48. And this took 2 minutes and 42 seconds. So that's, what's that, 60 is 120, 162 seconds. Is that okay so far?
Yeah.
So what I'll do is I'll do 2.3 million minus 0.48 million over 162. So times a million. So that's 11235 kilograms per second. That's how much fuel is coming out. So that in 2 minutes and 42 seconds it loses the amount I gave. Okay, so are we okay at that much? Yeah. Now, I also tell you how fast the fuel is coming out at. It's coming out at 3124 meters per second. So you know then that force for the rocket would be how much mass per second is ejected multiplied by the speed. Yeah, so in this case it would be 11235 times 3124. So that's a large number, 350,98140. Now my question was actually, what was the acceleration?
How the
This is the formula we did in the lesson on for the gas, yeah.
Yeah.
The rocket
Okay.
science lesson, yeah.
This is for the thrust.
Yes, correct, yeah.
This is F.
Oh,
R they are same. You make
yeah, call it T if you wanted. It's the
Oh,
F
that's
here.
right.
and then you call it MA, so you can get.
That's it. So then we can get MA equals 35098,140. The A is 35098,140 divided by the M. But here's the slight problem. The M. What is the M?
Divided by 2 average.
Yeah, you need to average it because there's two masses, the start and the end. So, if I just do, what's it, 2.3 plus 0.48 divided by 2?
1.35.
Great, million. Okay. So here I get 25.25 meters per second squared. Is it now? Oh, my bad. I forgot something. What did I forget? So let me just write in first what the average mass is. The average mass is 1.39 million kilograms. And the force up here is 35098,140. What have I left out?
Force down.
Yeah, which is what?
G.
Yeah, which is 1.39 million G.
Yeah.
So really I should have had MA equals 35098,140 minus 1.39 times 10 to the 6th times G, the total force. So dividing by the M, which is 1.39 times a million. Now I've got my answer, hopefully. 35098,140 minus 1.39 times 123 times 9.81 over 1.39 times 123. 15? It's off a little bit. I'll fix it. I don't think I typed in anything wrong there. 35098,140 minus 1.39 times 10 to the 6th times 9.81. 1.39. Yeah, the answer should be 15.4. Did anybody get that? 15.4, yeah. Meters per second squared. Okay, I'll fix that.
Did you use the average weight as well?
Yeah. Yeah, you'd have to, yeah, because the mass is changing.
Well, did you send that email for the people? Did you send that email because you skipped the first class? What did you say? It's okay.
I don't know. I will send it to Isabel. I just send the email to Isabel that I come late.
Okay, let's have a look at the next one. This one. Nobody got this. Nobody got this.
Wait, I did.
Did you? Partial or full?
Oh no,
Partial, yeah.
I did this.
Did you get it right? Did you get it right?
I don't know.
You can check on your phone if you want. Oh, my picture's messed up. A train moves 39 meters in the first, then 37, then 35. How far does it travel until it is at rest? That was a little hard, but I thought maybe somebody would get it. So if you look here, in the first second the train travels 39 meters in 1 second. Then in the next second it travels 37 meters. And then the last second it travels 35 meters. Okay? So, if you look here,
400.
could be, we'll see. If we look here, you could do this as a maths problem, because if you notice this is an
Only ones.
AP. But anyways, UBATS. Let's look at from here to here. What's the U? We don't know. What's the V? We don't know. What's the A? We don't know. What's the T? 1. And the S? 39. We don't have enough information, right? Let's look at from here to here. What's the U? We don't know. The V? Don't know. A, T, 2, S, 39 plus 37, 76. Yeah? Yes? So here we can say, look, S, look carefully, S, are you watching now? S equals U, T, plus a half A, T squared. S equals U, T, plus a half A, T squared. What's T squared? Half of it? 2A. This is an equation with U and A. This is an equation with U and A. So can you find U and A? You can. I won't do that because you know how to do that. I'll just type it in on the calculator. 1 half 39. 2, 76. So you get U is 40 and A is minus 2. So we want to know how long until it's at rest. So U is 40, V is 0, A is minus 2, T we don't know, and S is what we want. What formula could I use? V squared equals U squared plus 2AS. So then S would be 400, which I think is what you said, Fuang.
No, we don't have that.
I think I
You
will.
gave us, you have a correct answer is 500. Yeah.
Is it? Then I'm so sorry. It should be 400, then I'll fix that, don't worry.
How you know the answer? The answer is not correct.
No.
It says it's on the...
Check your Moodle.
Yeah, if you check Moodle, it says it.
You check your score. Tell me.
Yeah, it says 11 23. Is it? Is that?
Okay, AP.
Yes, it...
Like you said, AP.
Arithmetic sequence, isn't it?
The A is 2.
So if we did it in the exam,
That's fine. It won't be like this in the exam. It won't be quite... They won't be quite like this. Okay. Alright, next one. What's next? Yes. I thought everybody would get this right, but no. So, the book is 1 meter above your head. Is that a vector?
Yes.
True.
Why?
Somebody tell me, please.
so there's a difference and
There's a what in direction? Not quite the right word.
Isolation.
No. Begins with an M.
Magnitude.
There's a magnitude and direction. Yeah.
You only have 15 minutes.
But what is the
Yeah, loads of time.
above your head?
You like that question, yeah? Do you say false?
Yeah.
Okay. pendulum starts at amplitude. It's swinging back and forth. It swings 5 centimeters either side, and it takes half a second for each swing to fully complete. How fast is it traveling after 5.1 seconds in centimeters per second? So, what number is this now? 11. Okay, so what you have here, here's the pendulum, and it's swinging back and forth. So this is simple harmonic motion. The amplitude, I said, was 0.05. The time was 0.5?
Yeah.
Yeah.
Yeah. Okay, so we can get omega. What's the formula for omega?
2 pi over t.
2 pi over t. So the omega is 12.57 radians per second. Now, your formula you have for V is A omega sine omega t, which in this case will be 0.05 times 12.57 times sine 12.57, and what's the t?
0.5.
Say again, Musharif?
0.5.
5.1.
Yeah, okay.
So let's just hit this in on the calculator.
Why is 5.1?
That's not what I asked.
What is
How fast is it traveling after 5.1?
Yeah.
Okay.
Hmm? 0.05 times omega times sine omega t. Don't forget to be in radian mode. Meters per second.
That's a bit really radius, huh?
Yep. So that's 59.8 centimeters per second. Now I do wonder if I typed that in wrong. It seems a bit big. Let me try again. Sorry. Yeah. 59.8. Is that the right answer or not?
No.
No, what did I say?
6
6 point?
Yeah.
0.05 times 4.5
Hmm.
times
That's A.
0.60, and then that's meters, right?
Yeah. So it'd be 59. Yeah. So my answer then is wrong for this one. I'll fix it.
Yeah, times 160.
Yeah. So 59.8 then. So let me edit this question then. Okay. Next one. This one. A trolley traveling at 1 collides and sticks with an identical stationary trolley, and they move off together. At what speed?
Yes.
Okay. 12. So, trolley here, mass m. Trolley here, mass m. U1 equals 1. U2 equals 0. And then they move off together at v. So what's the momentum beforehand? m1 u1 plus m2 u2 equals mv. Cancel, cancel, cancel. V is a half. 0.5.
I got one. I don't really know why. But, yeah.
That's it.
And when you want
good question. How did you?
Can we see?
There's me. I'm so surprised that so many people got this wrong because I got such silly answers like, your teacher weighs 1 kilogram, what's his mass? I think somebody said 10 grams or something. Like,
1,000.
you said 1,000 kilograms? Yeah.
I think I take the thing.
Why? Why people's brains stop working? You know that answer couldn't possibly make sense. 1,000 kilograms?
No, because I remember this.
Oh, but use common sense. Common sense. How could your teacher weigh 1,000 kilograms?
Because there's so much information.
Yeah, information's not that heavy though.
But still, it's 101. It's too much.
No, it's not.
Why is it much? 101?
I take offense to that.
What do you mean too much?
Yeah, like it's saying 101. I think your weight should be like 80.
Oh no, goodness no. I'm more than 100 kg.
You're 101.
No way.
I'm more than 100 kg, for sure.
Less.
It's nice that you think that, but it's true. Weight is one...
You're not old.
It's nice that you think it, but I trust you, I'm not 80 kg or 85. I'm at least 100.
At least.
No way.
Yeah, wait. 100, now I said the weight was 100 kilonewtons, 1 kilonewton, so that's 1,000 newtons. So that means mg equals 1,000. So m is 1,000 over g. It's like 101 or something, isn't it?
Yeah, 102.
102. What? What?
I said 1,000 because like and newtons is like 1 kilogram or something.
What do you mean or something or what? There's a...
No, like I did it without the formula.
And what have you learned?
That's wrong. That's wrong. Like the right way.
Yes?
But
You're thinking too much.
no.
Yes, you are. Right, 102.
That was the first question I had.
That, yeah, well,
So you
the questions were randomly shuffled for everybody, so... Okay.
I didn't see this question for me.
You must have. You skipped it.
Oh.
Right, so this one here, you have... how much is it? 500. Is this one here? It's not so bad. 500 kilograms, and it's listed 2 meters by a truck. Here, it's kinetic energy, 0. Potential energy, at the ground, 0. At the top, its kinetic energy will be 0, and its potential energy will not be 0. So this came from the truck that was lifting it up. So the amount of work that the truck did was to give it the potential energy. So it's just mgh, which is 500, 9.81 times 2, which is 98100.
Yeah.
One,
No, just one. Oh.
Yeah.
1,000. 1, 2, yeah, 98 joules.
Yeah.
Now what unit did I want?
Yes.
I said give it in joules. So 9810.
I think it's a longer way.
Got the same answer?
Yeah.
That's good. Right.
I made work and then made it kinetic energy. You know, I got
Oh
work.
yes, longer. Right. Now this one here, I think everybody got this answer wrong by factors of 1,000 or 1,000,000. Everybody screwed up here with the time. What's the time here?
91 milliseconds.
Yeah.
Milliseconds. So here, what is this? 200 kilograms. So again, it's 200 kilograms, and it's listed a distance 2 meters. So we know what the work is. Is this the same as the last question? No, was 500. So the work MGH 3924. So what's the power, the formula for power? Work over time. And what's the time here? 981 milliseconds. So that's 4,000 watts. Now, do I want watts? I want kilowatts. So that's 4 kilowatts. Did you give us 4,000?
No, 0.4.
Uh-huh. 4. You're off by 10. 4 kilowatts is the answer. Okay. Lemons run off a cliff at 12 meters per second and the cliff is at 490. How far out in meters from the foot of the cliff will the lemon land?
What is lemon?
Lemons are these little creatures that run off cliffs.
What is that?
They're not real creatures. They don't really do this.
What was the reason?
Huh?
Yeah.
But that's the name of the lemon.
Lemon?
Lemon. There's a video game about them from 1990 if you want to look them up. Anyways, they're not real. They just run off cliffs. Okay. Right, can we do this one? So, this one, here's the cliff. Its height is 490 meters. And how fast is the lemon going? 12 meters per second. And splash. Flop. Yes. So, if we look at the vertical, UVATS, what's the U? Vertical. Vertical. Not 12. No?
0.
V we don't know. A minus 9.81. T we don't know. And S? S equals UT plus a half AT squared. So 490 times 2 over 9.81 equals T squared.
What is it from?
The time to die.
9.9.
About nearly 10 seconds. 9.99 seconds, so about 10 seconds. So, if we look at the horizontal now, UVATS, the U is 12, V don't know, A,
Why is 0, 0 the first one?
because there's no vertical. Vertical. A, T, so this is distance, speed, time. The distance will be 12 times 9.99. The speed multiplied by the time, which is 120 meters is the answer here. 120. This is all okay. A ball is thrown with speed 13 and an angle of 67.38. Alright, so this one, what is it? Projectile. So what is the answer for this? It's 13 cosine. I wanted the vertical. Yeah. 13 sine what? 67.38. So the answer is, and then make sure I'm back in degree mode, 12.
That's it?
Hmm? That was it. Ah, Fuang. What's the answer here? Energy can neither be created nor... Now you went with some great words. Decreated, which I like. Uncreated was another one maybe, was it? What else? What's the answer? Do you remember?
Try.
Very good. Destroyed.
Did you get it? Did you get it?
Dictionary helped a bit. with a Y. Do you spell it with an I? Well, I might give you the mark anyways for it if you spelled it with an I. No. Right, so the diameter of a coin is measured using a micrometer, as shown below, and then the cross-sectional area is calculated, and the area of the coin is 1.698 times 10 to the minus 3 meters squared. What is the radius? Okay. So the area, 1.698 times 10 to the minus 3 meters squared. Well, this one was okay. Pi r squared equals 1.698 times 10 to the minus 3. So r is 1.698 times 10 to the minus 3 divided by pi square root. Which is 0.02325 meters, but I believe I wanted the answer in millimeters.
I got it right, but you said the correct answer is 11.82.
Did I? Outrageous. Disgraceful. Right, so the answer should have been what?
23.2. Because you said millimeter.
Do you know what yeah. The answer should be 23.2 millimeters. Now, if you got that, I'll fix the marks for you now. 23.2. Although, that seems too big. That's a big coin.
Yeah.
That's like 4 centimeters. Yeah, okay. 23.2, was it? Yeah. Yeah, so your marks are slowly increasing. Yeah. Right, what's our next one here? Okay. Yeah, okay. So this one here at 20, the car accelerates with 2 and decelerates with 5. So here's the time and here's the velocity. So the car shoots up with acceleration of 2 and then shoots down with minus 5, or 5 if you want. And the total time here is 21 seconds. Yeah. Now, this one was a little bit hard. What you needed to do was to break this up into 2 shapes. This one you can call T1, and this time here you can call it T2. What's T1 plus T2? 21. Now, do I give you anything else? Or is that everything?
Do it like the other one, and I got the right one.
Yeah, no, I'm just making sure I didn't give you anything else. Now, do we know the speed up here? We don't. I'll just call this V0. Okay? You can say V0 over T1, what should that equal? V0 over T1, that should equal 2. Because remember, on the graph, what does the slope represent? The acceleration. And likewise, you can say V0 over T2, that should equal 5, yeah, or minus on both sides, so just 5 then.
Can you please explain V over T?
It's the slope. What's the slope of this line? rise over run, delta y over delta x.
So now for the
Yes, because the acceleration is 2. So you can say v0 over 2 equals t1, and v0 over 5 equals t2. v0 over 2 plus v0 over 5 equals 21. So a half plus a fifth, so you get 7/10 v0 equals 21. So v0 equals 30. So now you know that the height here is 30 and the base is 21. So how can you get, yeah. Three, 1, 5. That one was a hard one. That one was. A car is being tested for safety. The 2,000 kilogram is driven, I shouldn't say car, is driven by a test dummy into a wall. The car hits the wall at 20 and the front of it crumples. So what happens here is, there's the wall, there's the car, there's the front of the car, and this front of the car crumples over a distance of 1.1 meters. The car was 2,000 kilograms, and the speed when it hit the wall was 20. Is that all okay? So if we use our UVATS here, where's my pen gone? Okay, there it is. UVATS, the U, 20, the V, 0, the A, we don't know, the T, we don't know, the S, 1.1. Let's get the A. V squared equals U squared plus 2AS. Why is my A negative? Decelerating, yeah. And how can I get the force? MA. 363636 newtons with a minus, although if you gave minus or no minus in the answer, I think I still gave you the full marks. And I'm pretty sure I probably wanted it in kilonewtons, which in this case would be 364 kilonewtons.
Round it up.
Round.
Same.
Yeah. A boy is on a 3 meter, well, this one is straightforward. The turning force is force by distance. The force is 50, the distance is 3, so what's the turning force? 150. And the last one, for me, is three-force theorem. A 50 centimeter ball of 1 kilogram is hanging by an 80 centimeter string.
Can you solve it like cantilever?
Oh, you can, but it's not pleasant. This distance here is 0.5. This distance here is 0.8. So this distance here is 0.5. In total, this distance is 1.3. From Pythagoras, this distance will be 1.2 from Pythagoras.
Okay.
1.2 meters, 0.5 meters, and 1.3 meters. Yep. And then all forces act towards the center. So there's a tension here, T. There's a reaction here, R. And there's a weight, which is mg. The m is 1, so that's just 9.8 newtons. We can resolve this into... What's wrong, Adnan? This is T cos theta, and this is T sine theta. So you can say T sine theta equals 9.8. The verticals are equal. So that means t equals 9.8 divided by sine theta, and here theta is tan inverse 1.2 over 0.5. Um, 10.6.
Yes, that's my answer.
Good.
That's 4.08.
Oh, then I'll fix it for you.
But you didn't calculate the R, you calculate the T.
Oh,
Yeah, I'm wrong then.
I'm not finished. That's only the t. Rats, I wanted the or. So the or is t cos theta. Oh, but I needed the t.
Yeah.
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 10.6 cos theta. Um, 4.08. Is that what I said? Yeah. Let's hope I got 100.
You changed class, but you didn't 100.
We can't do that.
No. Why isn't it saying if it's right or wrong?
Because even the computer knows it's right because it's right because it's...
Maybe. Maybe. Okay. Right, let's have a look at your results.
You had 6 attempts, don't...
No, 6 attempts because there were 6 people here doing it.
Okay, never mind.
Yeah.
You know,
Let me stop the recording.